Okay, year 13, this is the C3 video for the 2011 paper, the January one, not the one that you're doing for homework. Okay, now the first question, I'm going to go through the whole video, and the first question isn't something that we've done yet, but what I'm hoping that you'll do is look through the way I've done this question, because it will be coming up in not too many lessons' time. Okay, so the first one is to express 7 cos x minus 24 sin x in this format here. Now this one comes up in most exams, so it's really, really important that you know how to do this one. So what we're going to do is we're going to have a look at the expansion of r cos x plus alpha. So we already know how to expand cos of a plus b. If we do cos of x plus alpha, we're going to get cos x cos alpha minus sin x sin alpha. Then if you multiply through by r, that gives us r cos x cos alpha minus r sin x sin alpha. Now what we've got to do is we've got to write this in this format. So if we write underneath 7 cos x minus 24 sin x, and then compare them, if we get rid of the cos x's there, then means that this 7 must equal r cos alpha. So the first thing to do is write down that r cos alpha equals 7. Similarly with this one, if we get rid of the sin x's there and there, we've got r sin alpha equals 24. And now what we're going to do is, if we call this one number 1, this one number 2, if we divide number 2 by number 1, so 2 divided by 1, we're going to get r sin alpha over r cos alpha. That's going to equal 24 over 7. The r's are going to cancel. Sin alpha over cos alpha, we should know, is tan alpha. So tan alpha equals 24 over 7. And then what we've got to do is, it says give the value of alpha to 3 decimal places. So we do the inverse tan of 24 over 7. So inverse tan of 24. Oh, in fact, just always double check this. This one is in radians. So change calculator to radians, and the inverse tan of 24 divided by 7 gives us 1.287 for 3 decimal places. Even though it doesn't say it, we're going to need to use r to find out part b, but also what we do in this question most of the time is we've got to work out what r equals. So if I do that over this side of the screen, now we know that r cos alpha equals 7. So if we square both that, that's going to be r squared plus cos squared alpha equals 49. If we did the same, so that's just not plus there, it should just be r squared cos alpha. If we do the same for number 2 here, r squared sin squared alpha, that equals 24 squared, like that. Then if we add those together, we're going to get r squared cos squared alpha plus r squared sin squared alpha, and that equals 7 squared plus 24 squared. If we then factorise out the r squared, we're going to get r squared cos squared alpha plus sin squared alpha equals 7 squared plus 24 squared. And we should know that cos squared plus sin squared just goes to 1. So we've got r squared equals 7 squared plus 24 squared. So just do Pythagoras on that. So 7 squared plus 24 squared, and do the square root, and we should get r equals 25. So we've got a value of r equaling 25. So whenever you do this question, like I say, I'll always ask you what r is, and they'll give you 1 mark for finding r. So all we do is we take the thing that's in front of the cos, the thing that's in front of the sine, then we do we do Pythagoras with that. So 7 squared plus 24 squared and square rooted. Anyway, all of that means that because it asked us to write r cos x plus alpha, we can now write that as 7 cos x minus 24 sine x equals r, which is 25, cos x plus 1.287. Okay, so now what I'm going to do, I'm going to get rid of this stuff. I'm going to have that. So anyway, we did this part here, which is the 1.287, which is down here. It says write down the minimum value of 7 cos x minus 24 sine x. It's only worth 1 mark. And the reason being is that if we write this as 25 cos x plus 1.287, the minimum or the maximum that this could ever be, because it's a cos of something, the minimum cos of anything can ever be is minus 1. So if we do 25 lots of this, the minimum that could ever be is going to be minus 25. The maximum that it could ever be, this thing here could only ever go to 1, so the maximum is going to be plus 25. And that's why it's only worth 1 question, because once you find out the value of r, the minimum is going to be the negative version of that, the maximum is going to be the maximum version of that. So, for the final 5 marks, we've got to solve this to 2 decimal places. Now, they're not going to ask us to do part A and part B, and then ask us to solve this a different way. We can write this thing here, as we know. 25, in fact, I've written it here. So 25 cos of x plus 1.287. And we're going to set that equal to 10. That's going to be our first mark. The next thing we're going to do is cos of x plus 1.287 equals 10 over 25, or 0.4. Now, we're solving this between x is in between 0 and 2 pi. So what we're going to do is we're going to say cos of a equals 10 over 25, and then change these limits. So now a is going to be between 1.287 and whatever 2 pi plus 1.287 turns out to be. So then we're going to draw the cos graph. So that's going to be pi, that's going to be 2 pi, that's going to, oh no, sorry, that's going to be pi, that's going to be 2 pi, that's going to be 3 pi. If we work out this value here, 2 pi plus 1.287, that's 7.5701. So we've got cos of a is 10 over 25. That's going to be that solution there, that solution there, that solution there, and potentially that solution there. So 10 divided by 25 is 0.4. If we do the inverse cos of that, we get a equaling 1.159. This one here is going to be 2 pi minus that. Which equals 5.124. We've got this one here, which is 2 pi plus that. which is 7.442, which is just inside, which is just less than 7.5701, which was our upper limit. However, this one here, 1.159, that's not within that limit. So these are our two solutions for A, but remember A is x plus 1.287, so this is just like in C2 question. Now I've got to take away 1.287, so 5.124 minus 1.287 is 3.837. 7.442 take away 1.287 is 6.155. Now that was 11 minutes on a question that you guys haven't come across yet, albeit you've come across bits and pieces of it in C2 and stuff that we've done in C3. The different parts are going to be the part A and part B, so that's the bit that I really want you to focus on there. And then once you understand part A and part B, part C should be just a repetition of stuff that we've done in C2. But at the moment, I don't need to get too hung up on this, because it's mostly the questions that you've done so far that you need to get A-OK at. Okay, so let's move on. Question 2. These are Harry's favourites, even. So we've got to express this into single fraction in its simplest form. So 4x minus 1 over 2 bracket x minus 1. And then x over minus 3 over 2x minus 1. So 2 bracket x minus 1, 2x minus 1. So what we're missing from the left-hand side here is a 2x minus 1. So if we multiply top and bottom by 2x minus 1, then we're going to have a common denominator. So let's now sort out the numerator. 8x squared plus 1 minus 2x minus 4x, and we've got that minus 3 there, all over 2 bracket x minus 1, 2x minus 1, is 8x squared minus 6x minus 2, over 2 bracket x minus 1, 2x minus 1. Right, I can see that everything on the top is equal, or even numbers. So I'm going to divide top and bottom by 2. So that's going to be 4x squared minus 3x minus 1 over x minus 1, 2x minus 1. So I've cancelled out that 2 down there. But then factorise the top. 2x. Now let's go with the 4x. And x minus 4 plus 1, so x minus 1, 2x minus 1. These cancel, leaving you with 4x plus 1 over 2x minus 1. Okay, so the solution to this one, 4x plus 1 over 2x minus 1. Again, what I'm hoping that you're doing is just pausing the video, having a go at the question first, and then seeing if you get the same answer as me. Okay, question B. Show that f of x equals this, given that f of x also equals this thing here. So we know that this bit here is the same as this one. So we've got 4x plus 1 over 2x minus 1 minus 2. Now again, this comes up all the time. What we've got here is we've got a fraction take away a number. So in order to do a fraction take away a fraction, we need to multiply top and bottom here by 2x minus 1. And also doing this, hopefully, will show that we've got a correct answer. So that's a, let's see, this works. So we've got 4x plus 1 over 2x minus 1 minus 4x plus 2 over 2x minus 1. So 4x take away 4x is going to be 0. 1 take away, so that should be minus 2 there. 1 take away minus 2 is going to be plus 3. That's going to be, so the x's cancel out, and then you've got 3 on the top over 2x minus 1, which thankfully gives us that answer. So the next thing we're going to do is we're going to differentiate our function of x and find f dashed of 2. So this is something a topic that you're doing at the moment. Let's see how we do this one. Now there's 3 differentiation rules. There's the chain rule, there's the product rule, and there's also the quotient rule. Now the quotient rule is one that I would use for this one. That's the one that you're going to be doing next. And the quotient rule is if you have u over v, that turns out to be v d when we differentiate. So if y equals this, dy by dx equals v du minus u dv all over v squared. So we've got u equals 3, we've got v equals 2x minus 1, so du is 0, and dv equals, that's du by dx and dv by dx, lazy way of writing it. dv is just 2. So v du is going to be v over du, which is 0. Take away u dv, we take away 6, all over v squared, which is 2x minus 1 squared. So that equals minus 6 over 2x minus 1 squared. And just before we do this part here, there's another way of doing this, and that's the chain rule. So you can write 3 over 2x minus 1, so y equals 3 over 2x minus 1. And what you can do is you can write that as 3 bracket 2x minus 1 to the power of minus 1. So if you bring things up, that's going to make it a negative power. Then if y equals that, dy by dx, you bring this power down, so it's going to be minus 1 times by 3 lots of 2x minus 1, then bring the power down by 1. Then you've got to differentiate what's inside the brackets. So if you differentiate that, that goes to 2, so you multiply everything by 2. Minus 1 times 3 times by 2 is going to be minus 6. Bracket 2x minus 1 to the power of minus 2, which then, if you bring this to the bottom, again gets you minus 6 over 2x minus 1 to the power of 2 on the bottom. So yeah, we're pretty confident that's the correct answer. Then if you've got f dashed of 2, you just got to substitute 2 into that. So let's make a little bit of room. So f dashed 2 is going to be minus 6 over 2 lots of 2, take away 1 squared, which is minus 6 over 4 to 9, which equals minus 2/3. And hopefully you should be able to do part A and part B of that comfortably, and potentially part C if you are happy using the chain rule when you've got stuff underneath. But again, like I say, you're going to be using the quotient rule in one of your next lessons, so you should be able to do that in 2 separate ways. Okay, question 2 done. question 3. Now this is what you've been doing with me in quite recent lessons actually. So we've got 2 cos 2 theta equals 1 minus 2 sin theta. Almost looks like a quadratic. But if you've got a quadratic, you've got to have them all as cos or all as sin. Now with the cos 2 theta, there's 3 different things that you can expand that to. Cos squared minus sine squared, 2 cos squared minus 1, or, but in this case, 1 minus 2 sin squared theta. So what we're going to do is we're going to substitute that in for this here. That way, we're going to have numbers, we're going to have sin thetas and sin squared thetas. So it's going to be 2 bracket 1 minus 2 sin squared theta equals 1 minus 2 sin theta. What we're going to do then is expand the brackets. 2 minus 4 sin squared theta equals 1 minus 2 sin theta. And then get it all over to the right hand side. So 4 sin squared theta minus 2 sin theta minus 3, right, minus 1. And it doesn't look like that factorizes. So if we then use the quadratic rule, so x equals minus b, so that's going to be minus minus 2 plus the minus square root of b squared minus 4 times a times c, so 4 times 4 times minus 1 all over 2a. So bear with me a second. I'm just going to pause the video, work out what it is, and then write down the 2 values. Bear with me. And so we get x equals 0.809 and x equals minus 0.309. Remember, x in this case is, we have this here, sin theta, so that's going to be sin theta equals this, and sin theta equals that one there. Now your calculator is probably still going to be in radians, so always double check in your head. Have I got it in degrees or radians? What do I need in this question? And it's asked for it in degrees. So the inverse sin of minus 0.309, so that's one, so I've got my calculator, is minus 18. And if I do the minus 809, we can do the sin graph in between 0 and 360, or sine graph. We've got minus 18, which is going to be the same as this value here and this value here, and 54 for these 2 values here. So that's going to be 54 degrees and 180 minus 54, which is 126 degrees. Minus 18 is going to be the same as this one here, which is 180 plus 18, which is 198, and 360 minus 18, which is 342. So those are the 4 answers for that question. Again, it's just another C2 question, should be relatively straightforward. Question 4. Joan brings a cup of hot tea into a room and places the cup on the table. At the time 2 minutes after Joan placed the cup on the table, the temperature 0 degrees of the tea is modelled by the equation that for A and K are positive constants. Given that the initial temperature of the tea was 90, again, initial temperature, they always have something like this, and as soon as it says initial, what that means is that T equals 0. Be on the lookout for that. And so the temperature was 90 degrees. So what we're going to do is we're then going to say that 90 degrees equals 20 plus A e to the minus k times by 0. So that's going to be 0. E to the power of 0 is going to be 1. So we've got 90 equals 20 plus a. So a equals 70. It says the T takes 5 minutes to decrease in temperature from 90 to 55. Show that K equals that there. So we know that A equals 70. And then it tells us that T equals T equals 5, and the temperature equals, so theta equals 55. So let's chuck that in. So we know that 55 equals 20 plus A, which we now know is 70. 70 e to the minus k times by 5. And then it's just a matter of being able to be confident with exponentials and logs and whatnot. So take away 20 and then divide by 70. So we've got 35 over 70, and that equals e to the minus 5k. Again, make sure you know what I've done there. So I've taken away 20 from both sides, and I've divided through by 70, and minus k times 5 is going to be minus 5k. Now the reason I've done it like this is because when you cancel out exponentials using logs, you can't have more than one thing. So I couldn't, at this first step here, just taken logs of both sides, because I haven't just got an exponential on one side. I've got something plus an exponential, or something plus something lots of an exponential. And that doesn't work. It's got to be just the exponential. So I've got 35 over 70, which is the same as a half. So if I take logs of both of those sides, that's going to be a log of a half equals minus 5k. So if we then divide both sides by minus 5, I'm going to get minus 1/5 log to a half equals k, which, if you have a look at the answer, isn't what we want. So let's have a look at log to the power of a half then. A half is the same as 2 to the power of minus 1. So that's minus 1/5 log of 2 to the power of minus 1 equals k. Now again, with logs, we should know that we can bring this power down to the front. So minus 1 times 1/5 is going to be 1/5 log 2 equals k, which is what they wanted. Okay, the next thing is find the rate at which the temperature of the T is decreasing at the instant when T equals 10. Give your answer in Celsius per minute to 3 decimal places. So it says, and the key thing about this is being able to pick out the keywords. And it says the rate at which it's decreasing. So if we're talking about rates, we're talking about differentiation. So if we've got theta equals 20 plus 70 e to the minus 1/5 log 2k, no, sorry, t, and we've got to differentiate that and then substitute in t equals 10. So d theta by dt, 20 is just going to go, and if we differentiate this, when we differentiate with exponentials, it stays the same, so it's still going to be minus 1/5 log 2t. Then we differentiate this and bring that to the front, so that's going to be multiplied by minus 1/5 log 2. Okay, and then you just substitute in your value of t, which I'm going to do on the calculator. I'm going to pause the video. I'm going to put in the value of t here equals 10, and then you should get an answer. Okay, and that comes out at minus 2.426 degrees Celsius per minute. Okay, so next one. Question 5. So what we've got here is we've got a curve which cuts the x-axis at A and B. And the first thing it asks us is write down the coordinates of A and B. So if we've got a function of x equaling 8 minus x bracket log x, we've got to find out where y, or f of x here, equals 0. So we make this bracket equal 0, then x equals 8. We make this thing 0, so log of x equals 0. So that I think equals 1. We got 1 there, and we got 8 there. Okay, find f dashed of x. Now, this goes on some of what you've done so far, and you've done some bits of this, but you haven't done other bits of it, and that's be able to differentiate logs. What you should notice here is you've got to differentiate this, and it's 8 minus x times by log of x. So what you need to do is that's the chain rule, and we should know that the chain rule is u dv plus v du, where u equals 8 minus x and v equals log x. So du is dead easy, du is just 8, so dead easy. Du is minus 1, and dv, when you differentiate log x, you get 1 over x. So u dv plus v du, we get 8 minus x, so f dashed of x equals 8 minus x over x plus minus log of x. That's it, that's f dashed of x. Okay, so now we're going to show the x-coordinate of Q lies between 3.5 and 3.6. So if we go back up here, Q is the turning point. So if it's a turning point, again, from core 2, you know that turning points are where the gradient is 0. So here, this is our gradient. So we've got to show the gradient is 0 somewhere between 3.5 and 3.6. So what we do is we substitute 3.5 in. So if we do f dashed of 3.5 and f dashed of 3.6, that means what we're doing is we're substituting 3.5 in as a gradient, substituting 3.6 in as a gradient. So if we just put that into the calculator, again something I'll do on pause. Okay, substituting in 3.5, you get 0.03 295 ... Substitution in 3.6, you get minus 0.0587 ... So therefore you need to say change of sign indicates a root in the interval 3.5 to 3.6. Okay, show that the x-coordinate of Q is a solution to this. So now what we do is we're finding the actual x-coordinate. So we're trying to set our gradient equal to 0. So if we do it over this side here, we're going to set 0 equals 8 minus x over x minus log x. So then we've got to solve for x equals. So if we bring this over to the other side, we're going to have log x equals 8 minus x over x. If we then multiply that by x, so we've got x, log x equals 8 minus x, and we then add this x over. It's going to be x log x, so plus, that, x log x plus x equals 8. If we factorise the x out, it's going to be x brackets log x plus 1 equals 8. And we divide through, x equals 8 over log x plus 1, which is the other way around of this thing here. And then to find an approximate x coordinate for the iteration, so if we go down to part E now, we've got this part here. So they've asked us to do this part up here, so x equals this, which we've just done on the left-hand side there. And then they've put it as an iteration formula because we've got x n plus 1 over 1 plus log x to the n. So therefore it's an iteration formula where you put the answer in, turn the handle, and then you should get the next one. So x0 equals 3.55. You then substitute 3.55 into this, and you should end up getting what x1, x2, and x3 are. So if we do 8 divided by, then in brackets, 1 plus log of 3.55, you should get 3 points, so it's to 3 decimal places, so 529. Being really careful with your rounding. Even though we've written this here, what we need to make sure we do is we put the answer that's in our calculator in for the next one. So we add 1, and then 8 divided by that answer. And we get 1.766. Doesn't sound right. It's because it's not right. Let me just do that again. Okay, the issue being that I didn't log it. So you do log of the answer plus 1, then 8 divided by that answer, and there we go. 3.538. Then we do log of that plus 1, 8 divided by that. Bear with me. And that's going to be 3.534. And that should be that question done. Again, make sure that your answers look right, because with iteration, they should be getting closer and closer to an answer. So the fact that I had 3.55 for x0, 3.529 for x1, the fact that I had 1.7 something there is a huge step away from these first two. So that's how I know I made a mistake. I'm not saying that's why I made the mistake, so I can point it out to you and use it as a good teaching point, but it's not a coincidence either. I'm just that good. Okay, let's move on to question 6. So these are the function ones. Now these ones, no one ever likes. I don't think they're too bad. Okay, so the function is defined by this here. Find f to the minus 1 of x. Now, f to the minus 1, if you've done your revision for C3, you know that f to the minus 1 is the inverse function. So the first thing we do is we write it out as y equals 3 minus 2x over x minus 5. You've got to rearrange to get x equals. Now the issue being is that we've got two different x's here. So in this case, if ever we've got a fraction, we're going to multiply this up the other side. So we've got xy minus 5y equals 3 minus 2x. Once you've done that, you get all the x's on one side and everything else on the other side. That's going to be xy plus 2x equals 5y plus 3. Factorise out the x. X bracket y plus 2 equals 5y plus 3, divided by x equals 5y plus 3 over y plus 2. And then once you've got x equals what we have here, you then replace the x with f to the minus 1 of x. Replace all the y's here with x's. That equals 5x plus 3 over x plus 2. And here we are on question 6 with a nice easy question. As long as you've done your revision, that should be a nice easy question. So now we've got to write down the, okay, so what we've got here is we've got g of x. And that's this graph here. It says write down the range of g of x. Now range just means the inverse. So it means all the y values. So we can see the y values here. They start down at -9 and they go up to 4. So we can write down that g of x is less than or equal to 8. It's greater than or equal to -9. Easy. Now we don't actually have our g function here. We're not told what it is. All we can do is we can just see it. It says find g of 2. Now what this means is that you put 2 into the g of x function. So substitute x in as 2. Whatever we get out, we get our number out. We then substitute that in again. So here it's telling us to substitute 2 into our g function, find out what the answer is. Whatever that answer is, we substitute it back into the g function. The trouble is we don't have g of x equals something. But what we do have is we have the graph, and we can see that if we substitute 2 into our graph, when x equals 2, y is going to be 0. So g of 2 equals 0. And then what we do, whatever that answer is, we substitute it back into the other g. So then we do g of 0. We can see that if we substitute 0 into our g function here, then our x value is 0, we get -6. So g of 2 equals -6. Very, very easy if you can understand what it is, that the link between this graph here and the function that is g of x. Okay, finally we've got to do fg of 8. So what we're going to do is we're going to substitute 8 into the g function. So this is our g function here. Substitute 8 in, and we get 4 out. And we're going to substitute 4 into our function f. If we go up here, we've got to substitute 4 into this one. That's going to be 3 take away 2 lots of 4 all over 4 take away 5. So 3 take away 8 is going to be -5 over -1, which equals 5. Wow, that's loads of questions. Okay, so now E, we've got to sketch g of x modulus. So the modulus of this graph here, and we should know that the modulus just bounces it up off the x-axis. So where it goes below the x-axis, we're going to go up that way. So when you sketch it, obviously it's going on a separate graph. It just comes in there, bounces off at 2, and then goes up. And instead of going through at -6, it's going to go through at +6. So that's what that one looks like. Very, very easy. G to the -1 of x. This is the inverse function. And again, as long as you've done your revision on this, it should be very easy. Now, our g of x function looks like this, and it goes through at 0, 2. So 0, 2, and it goes through at, no, sorry, try that again. It goes through at 2, 0, and it goes through at 0, -6. So, the inverse function, g to the -1 of x, is going to go through the other way around. So it's going to go through at 0, 2, and at -6, 0. So -6, 0 is going to be over here, and 0, 2 is going to be up there. And then it's just a reflection, and it's a reflection in the line y equals x. It's going to turn in at that on there, and go off in that direction. As long as you've said that it goes through at 0, 2, and -6, 0, that's it. That's all the marks that you need. Well, that's all you need to do to get the marks. nice 4 marks. State the domain of the inverse function of g. Now, again, this is a revision thing, so these points, I mean, it's a very, very good question to do revision from, because this is pretty much the whole topic. Everything that we've done here is the whole topic. And the domain of the inverse, so the domain of the inverse equals the range of the original. So the range of this we said was between, so the y values, that's between -9 and 4. Therefore, the domain of this one, x, is going to be between -9 and 4. So the domain of the inverse is the range of the original. And the range of the original one was between -9 and 4. Hopefully that makes a load of sense. And let's go through to question 7. Okay, so we've got to do this question. This is differentiation. So you can almost relax at this because you're not expected to know this now, so there's no pressure on you to do this. But watching this does get you ahead of the game. So as I said earlier, what we've got here is we've got a quotient. We've got y equals something over something. So when we differentiate that, dy by dx equals v du minus u dv all over v squared, which is why the bottom is v and why the bottom of this one's going to be v squared. So what we need to do is we need to know what the differential of sine 2x is, or sine x, and we need to know how to differentiate 2 plus cos 2x. Now when you differentiate, quickly over here on the left hand side of the screen, if you differentiate sine x, you get dy by dx equals cos x. And if you got cos x, differentiate, and you got sine x, except that when you differentiate anything that begins with the letter c, it's negative. Now it's a handy rule that one of my students actually a few years ago had spotted. Anything that begins with the letter c, differentiate it and it's going to be negative. Also, if you've got sine of 2x, so y equals that, dy by dx is going to be cos 2x, but you have to do whatever the angle is here, you have to differentiate that and stick it in the front. So differentiate 2x, then go to 2. So with that in mind, if we do du here, that's going to be 3 plus 2 lots of cos 2x, because we differentiate sine 2x and get cos 2x, differentiate the 2x here, and stick that on the front. So dv by dx, I was lazy with that. Don't ever forget that in your exam now. So, oh no, so what on earth am I doing? If you differentiate the 3 here, that just goes. There's no 3 plus. It's my mistake. So here, if you differentiate the 2, that just disappears. So if we differentiate the cos 2x, remember that begins with a c, so it's going to be minus sine 2x. Then we differentiate the 2x, and we get 2. So minus 2 sine 2x. And then because it's a quotient, we're going to use this one here. A quotient just means a fraction. So it's going to be v du, so it's going to be 2 plus cos 2x. That's v and du, which is 2 cos 2x. Minus u dv, so that's minus 3 plus sine 2x times by minus minus 2 sine 2x all over b squared. So all over 2 plus cos 2x squared. So now what we've got to do is we've got to simplify that so it looks like this. I get rid of all this stuff here, give me some space to work on. So then, if you'll notice that, you'll notice that there's no squares here, so hopefully things should start to cancel out. So we'll have a look at that. So we've got so multiply this by that, and that's going to be 4 cos 2x plus 2 cos 2x times cos 2x, that's going to be 2 cos squared 2x minus, I'm going to stick all this in brackets, so that times that is going to be minus 6 sine 2x. If we do that times that, it's going to be minus 2 sine squared 2x. So if we bring that out, 4 cos 2x plus 2 cos squared 2x plus 6 sine 2x plus 2 sine squared 2x all over 2 plus cos 2x all squared. Now we notice at the top at the moment up here doesn't look like this here because it doesn't have any sine squared 2x's in. But if we notice, we have got, what we have got so far is we've got the 6 sine 2x there, and we have got the 4 cos 2x here. But we've got this plus 2 instead, but we've got this thing here. So, giving us a little bit more room, we want to keep the bits that we've circled, and we somehow want to get rid of this and end up with 2. So if we write that out, change the colour, we've got the 6 sine 2x plus 4 cos 2x, which you wanted, plus, and then if we factorise out the 2 here, we've got plus 2 lots of, then write this one first, sine squared 2x plus cos squared 2x all over 2 plus cos 2x squared. So we've got, this is what we wanted, this is what we wanted, and we wanted this just to go to 2. And what we factorise out there is sine squared plus cos squared, which we know that sine squared plus cos squared, this just equals 1. So in doing so, we can then write that out. And what I might do is, in the exam, just write down that sine squared 2x plus cos squared 2x equals 1. Because it's a show that question, they're expecting you to be quite explicit with how you show it. So really, really put in every line of work in. So then you end up with 6 sine 2x plus 4 cos 2x plus 2 all over 2 plus cos 2x squared. Job done. Now, the next bit, find an equation of the tangent to C. So going back to C1, in order to find a tangent, we're going to use y minus y1 equals mx minus x1. Now, we haven't sort of spoke about this in C3 yet, But this is another huge part of it, because they're always asking for like the equation of the tangent or the equation of the normal. And so what we need is we need to have a coordinate, we need to have a coordinate, and we also need to have the gradient. Now it tells us here that the x-coordinate is pi over 2. So substitute that into this, it's going to get a y-coordinate. And in doing so, that gets us 1 mark. So we've got x equals pi over 2, which again you'll notice is in radians. So set your calculator to radians. And then we type that in. So that's going to be 3 plus sine pi. Sine of 180, or sine pi, which is sine of 180, is 0. So that's going to be y equals 3 over, and cos 180 is minus 1. So cos lots of 2x, that's going to be 2 lots of x, which is going to be pi. Cos of 180 is minus 1, so 2 plus minus 1 is going to be 1. So y equals 3. We've then got to substitute this into our gradient function here. That'll get us a gradient. So dy by dx equals, and we substitute that in. So sine of 180 is going to be 0, so there's going to go to 0. Excuse me. And for cos 2x, so that's going to be 2 lots of our gradient, which is going to be 180. Lots of 180, so cos 180 is going to be minus 1, so it's going to be minus 4 plus 2. And then if we substitute pi over 2 into there, that's going to be 2 lots of pi over 2 is going to be pi. Cos of pi is going to be minus 1, so 2 take away 1 is going to be 1 squared. That's going to be over 1 squared. That is equals minus 4 plus 2 is going to be minus 2 over 1, leaving us with a gradient of minus 2. Once we've done that, we can substitute that all into our thing that we use so much in C1, which is our y minus y1, so that's going to be y minus 3 equals gradient, which is minus 2, bracket x minus x coordinate, which is pi over 2, y minus 3 equals minus 2x plus pi, and y equals minus 2x plus pi. And that's it. And we can see that our exact constants are minus 2 and pi over 3. Pi over 3 is still an exact number. 3.14 isn't an exact number. You put it in decimals and rounded it, but pi is exact. Okay, so that's question 7 done. I reckon it's just question 8, and then we're done. Lovely. So, question 8. Given that if you differentiate cos, like we said earlier, we get minus sine x. Show that if we differentiate this, we get sec x tan x. So sec x, y equals 1 over cos x. Again, what that looks like to me, looks like the quotient for the third time. So u equals 1 and v equals cos x. Now du equals 0, dv equals, if we differentiate cos, we get minus sine x, as we've got there. So then the quotient rule is v du minus u dv all over v squared. So v du is going to be cos x times 0, which is 0, minus u dv, so minus this times this, so that's minus sine x, all over cos squared x. So that gives us, so that's dy by dx, or d by dx. That's going to be sine x cos squared x. Now what we can do is we can have that as cos x, which we can then say sine x over cos x divided by 1 over cos x. So imagine doing that the other way around. If you're going to multiply fractions, sine times 1 would be sine x. Cos x times cos x equals cos squared x, or cos x cos x. Sine x over cos x equals tan x. 1 over cos x equals sec x. So that's how that works. So you've got to use the quotient rule, and you need to say that, therefore this is tan x, and this is sec x. That's it. Now the next question is one that, obviously it's on the last question, so it's going to be trickier. So we've got to find dx in terms of, so dx by dy in terms of y. And this is dx by dy, not dy by dx. They've actually been kind of with this, even though it's a tricky question. They've broken it down to two parts. Very often they'll just say find dy by dx, but here they've got us to find dx by dy first. So x equals this, dx by dy. We know that if you differentiate x, we get sec x tan x. So this time we've got sec 2y. That's going to be, if we differentiate sec x, we get sec x tan x. So differentiate sec 2y, we get sec 2y tan 2y. Then we need to differentiate the 2y and see that in the front, so that's going to be 2 sec 2y tan 2y. And that's what dx by dy gives us. Okay, so the last bit. Again, the first mark in this, it's the very end question, but the first mark is dead easy. It's spotting that you have to do dx by dy for part B here. Then as soon as you've got dx by dy, whatever you've got for that, doesn't matter even if you've got the incorrect answer. The first mark is for finding out what dy by dx is. So dy by dx is simply 1 over dx by dy. So you just turn it upside down. And what I would do for that one is I'll probably rewrite dx by dy. So sec 2y is going to be 1 over cos 2y. And so I'd say that's going to be 2 over cos 2y. And tan 2y is going to be sine 2y over cos 2y. So we've got dx by dy equals 2 sine 2y over cos squared 2y. So dy by dx, you just flip it upside down. So dy by dx equals cos squared 2y over 2 sine 2y. In fact, I've just had a look back at this here. I wouldn't do that at all. Sorry. So dx by dy is this one. So dy by dx equals 1 over 2 sec 2y tan 2y. Now we know that sec 2y is x, because we've got to find dy by dx in terms of x, which means we can't have any y's there. So sec 2y just gets replaced by x. So it's going to be 1 over 2x tan 2y. And now we've got at least 2 of our marks. So we need to know what this is in terms of x. And this is the bit where you've got to sort of try and think, how do I get from tan to sec? And this goes back to, we haven't used it so far in the exam, but sine squared theta plus cos squared theta equals 1. So if we're talking in terms of tan, that's going to be sine over cos. So if we divide everything by cos squared, sine squared over cos squared is tan squared, plus 1 equals sec squared. If I get rid of the theta and put y, you know, tan squared y plus 1 equals sec squared y. Or even if you put 2y instead. Now we know that sec 2y it's going to be x. So x squared is sec squared 2y. So we can say that tan squared 2y plus 1 equals sec squared 2y, which we know is x squared. So again, looking down here, we want to get rid of the tan 2y. So if we have tan squared 2y equals x squared minus 1, and then tan 2y equals the square root of x squared minus 1. Don't make the mistake of doing the square root of x squared as x and the square root of 1 as 1. You can't do the square root of x squared minus 1. So you've just got to put it in the square root sign. So we know that tan 2y equals the square root of x squared minus 1, which we substitute in here, and we get dy by dx equals 1 over 2x, and instead of tan 2y we have this thing here, square root of x squared minus 1, and that's it. Excuse me. So it's a tricky question, but it's not horrendous. But the main thing that you've got to pick up on this question, I know that you guys won't have done this yet, so it's very, very easy to switch off. But what I would say is a key thing to this question is, first of all, you need to know this anyway. So if you've got to differentiate sec using this, you're going to use the quotient rule. Then whenever you've got an x and you've got to differentiate, you do dx by dy. Don't try rearranging it first. Do dx by dy, get whatever you get, and then the next bit here, dy by dx, you just flip it upside down. And as soon as you flip it upside down, you've got to try and get rid of whatever it is you have. So dy by dx, you're going to have it all in terms of y, so 3y plus square root of y cubed or something, whatever it turns out to be. Then what you've got to do is you've got to then try and get rid of these y's and get them back in terms of x here by using this thing here. Okay, thank you very much, and please make sure that you watch this a few times. Not because it will make me awesome in terms of RescorlaMaths, like, share, subscribe, but because the more familiar you get with all these papers and all these questions, the easier it's going to be to make sure that you get the grade in C3. C3 always sees a drop-off in grades, so if you could try and address that by doing as much as early as possible, it will really, really make a difference. Okay, thank you guys. I won't take up any more of your time, unless you rewind it.